original, suppose it is G0 of S plus delta S. But it is not that always it will appear in the additive form. It can appear in many other form. So this is one possibility which is called additive uncertainty representation. It can be many other. Unless I write a few, it won't be clear to you. So this is one possibility. Another one is multiplicative. How? G0S into I plus delta of S. This is all multiplicative, you see. Now it's a relation as a multiplication. Now this fact, it can be later, it can be earlier. So in one case it would be called input multiplicative, in other case it would be called output multiplicative. That is, it can be either this way or even this can also be. If I draw the block diagram, I believe it would be easy for you to understand. The uncertain part is being represented by the delta. This is suppose ideal output y0 and this is suppose y. So in that way, this whole thing as a whole, this will be your actual plant, which is represented by G delta of S. It is a name which we are giving, right? G delta of S equals to G0 of S plus delta of S. This is the additive uncertainty representation. Now, how can you represent the other one? The input one. Same thing, the same way we have to use the block diagram. If I draw G0 in this case, what will be my G delta? No, as a whole.
G0 plus delta.
This is nothing is there means it is I.
Right? Into I plus, so that G0 into I plus delta.
About the representation, yes, of course, like in that case, if you have to represent it in a multiplication way, you have to use this as a I, right? So now my question is, will it be G0 into I plus delta or I plus delta into G0? That is my concern.
I plus delta into G0.
Why are you saying I plus delta into G0? Like how to resolve this doubt?
Like a function. Pre-multiplied.
I plus delta into G0, but I plus delta of S into G0. But I still don't know, because some of you might be thinking G0 into I plus delta of S. But how to resolve that? Which one is correct?
So if we write y of s equals to g delta s into u of 0, then we will see g 0 of s.
That means, are you talking about that if in between, that is if you use another signal and then if we resolve, are you talking about that?
Yes. So this, I'm checking the u matrix is multiplied with g0 first.
U is not a matrix, U is a signal.
If I write y of s equals
Huh.
to g
Huh.
delta
Now you
s,
see, that is as a whole, you have two blocks. G0, that is one block, I plus delta of s, that is another block, right? Then you have to resolve, that is how, that is in the, this is a cascaded representation. Cascade means two blocks are there in series, right? Then how to write or how to find, that is which one is the correct representation. Let's see a general case. Suppose you have a cascaded representation of G1 of S and G2 of S. This is suppose Y, in between this intermediate signal is called W and this is suppose U. Then how would you write? Y of S, easily we can write G2 of S into W of S. The moment you do this, immediately it would be clear. Now W of S means G1 of S into U of S. Together we can call it G of S. Here also the same. Are you getting? Suppose this I plus delta of S, you consider this one as G2 and this is G0. Then that is as I did here, this block is appearing at the first. So here also I plus delta S will appear at the first, right? So that's why I said that maybe you introduce an intermediate signal and you apply this procedure, right? Whenever you have a doubt, you do this. So this is called a cascaded or series representation. So that is my first configuration, 1, 2, and then the third one. Right? So this is my third representation. Here the uncertainty, it appears in the multiplicative format, but which is also appearing at the output side. The uncertainty is at the output side, right? So that's why it is called output multiplicative uncertainty. Once again, here it is in the multiplicative format, G0 into something, and on top of that, the uncertain block delta, it is closer to the output compared to the G0, right? That's why it is output multiplicative. Now you see there is the delta block is appearing at the input side, so that's why it is now input multiplicative. Okay, what will be the representation? G delta equals to G0 into I plus delta, right? So the other one, G0 into I plus delta, right? This is the representation. So once again, the first one is the additive uncertainty representation. Second one, output multiplicative uncertainty representation. Third one, input multiplicative uncertainty representation. Or is there any doubt or did I make any mistake?
G0 into I plus delta S, it should be.
This one.
Okay, I saw the last line.
This one, input multiplicative. Okay. This one input multiplicative, this one output multiplicative, the first one is additive. There are 3-4 more. At this moment I am not introducing all of them because that will unnecessarily create confusion, but I'll have to give example one by one. Okay. But now we are almost about to end, but before that we have to check one thing, that is this delta. What kind of uncertainty is this? Because otherwise there will be a confusion. Last day, if you remember, I introduced mostly 3 types of uncertainties. What are they, Anika? Please check your copies and tell me confidently. What are they? Uncertainty classification, right? Unstructured. The second one is structure under which a special type is parametric, and the third one is lumped or composite, right? All this data, whenever, in most of the cases, when we are representing the uncertainty in this fashion, delta of S, it is unstructured. In most of the cases, even in the books also, when they write in this fashion, delta of S, like a frequency varying object, this type of uncertainty is generally unstructured. Now, in layman's term, what is an unstructured uncertainty? Like last day we discussed a little bit, that is why parametric is structured, and then what is the general concept about unstructured. Last day, that is, I hope that is all of you are confident about the term why parametric is structured. Because if you have a transfer function, say for example, last day also we discussed, you have a transfer function g of s equals to k by s square plus p1s plus p0. p1 varies in a range, it varies linearly. p0 also varies in a range, k varies in a range. As long as the range remains like if suppose P1, it varies in between 8 to 12. P0, it varies in between 25 to 30. And K, it varies between 4 to 8. Within all of the range is positive, finite, like in all of the bounded range, right? So for any type of variation within this range, the transfer function will not become unstable, or even the structure will not also change. Now here somebody can answer, what do you exactly mean by the term structure? That means if something happens, that is suppose due to any change of due to change of some of the parameters, if there is a possibility that is a zero can be added, or another pole can be added, then it is called an unstructured uncertainty, where we are not sure about its structure. Are you getting? As long as you have this k by a square plus p1s plus p0, then whatever may be the variation within this specified range, will there be any change in the structure of the transfer function? Only thing the poles can be, they will remain stable only. Only the poles can be like little bit here and there, right? The gain can be little bit higher or lower, but is there any change in the structure? Structure of a transfer function means in terms of its poles and zeros. So whatever may be the changes, even if all three change simultaneously, then also is there any possibility that a new pole or zero will come in, or an existing pole or zero will go off? Is there any possibility? It is not. That's why it is called a structured uncertainty. That is, the structure which was originally there, that we know, and there is no change in the structure provided there is any bounded change in the bounded variation in the parameter. That is the reason why parametric uncertainty is a structured uncertainty. Yes.
So there could be cancellation for certain z, p1, p2.
The cancellation will.
Sir, in terms of structure, we mean the presence of particular poles and zeros. So for certain values of p1, p0.
That's why, that is when I consider this one, that is there, it doesn't have any other things. Of course, that is if there is something which you wanted to probably mean, that is suppose there is s plus z, and then here you have s plus p1 into s plus p0, and then the variation is something like the possibility will lead to a pole zero cancellation, then definitely there will be a problem. We cannot readily put it under the parametric uncertainty. Good point, so. Have you understood what he asked? Although that is quite, it is like not very often it appears, but theoretically it appears, or even in practice also it may appear, we don't know. If really it appears, that is the variation of the poles and zero is such that for some particular arrangement this zero can be cancelled with the pole, then of course there will be a huge problem. And specifically if it is unstable pole zero cancellation, then of course we have to treat it separately.
But most of the time when the pole zero cancellation appears, the plant is already unstable.
No, pole zero cancellation, how does it related to the plant being unstable? Pole zero cancellation, that happens, that is what is the reason behind the pole zero cancellation? That is a lack of a controllability or the observability, right? So that is the problem in the structural property. We will discuss of course, but what you said, that this pole zero cancellation, it is not because of that. That is originally it is a problem with its structure. But what you said, that is also an important point. The remaining students, have you understood what you wanted to mention? That is this pole zero cancellation. Suppose if it happens, that is there is a pole zero cancellation, that is s by 1 plus s by 1. If it cancels, cancellation is undesired, still it won't cause a big trouble for us. But if it is a cancellation like s by s, or suppose s minus 1 by s minus 1, that means if the cancellation happens on j omega axis or at the right hand side, then it will lead to a lot of issues for us. When we will study internal stability, I will specifically show you that is why unstable pole zero cancellation causes lot of headache to us. Okay, so please you may note down that is a stable pole zero cancellation, although that is undesired, but it doesn't cause stability problem. Whereas a pole zero cancellation on the j omega axis or on the open right hand side, it may lead to instability. Once again, a stable pole zero cancellation, that means pole zero cancellation on the open left half, although that is undesired, but that does not create any stability problem, right? I hope you have understood. Whereas a pole zero cancellation on the imaginary axis or on the open left hand side may even lead to instability problem. We will learn that in detail when I will start internal stability. Then we will see that if this unstable pole zero cancellation, why that is very dangerous for us. So once again, in summary, the why parametric uncertainty is structured, because like due to this bounded perturbation or variation, there is no change in the structure of the original model or the transfer function. Keeping aside that the possibility of pole zero cancellation, right? That is once again, that is here originally what I said. The change in the structure means either addition of a new pole or zero or removal of a pole and zero. That is called change in the structure. But in this case, like when some of the parameters are like varying linearly within a range, there is no structural change here in the plant model. That's why this parametric uncertainty is a form of structural uncertainty. Okay. Now, but this confusion still remains. Then, what do you mean by an unstructured uncertainty? Suppose I'm giving you an example. Suppose you have 1 by s square plus s plus 1. Okay. Suppose this is a second order underdamped system. Okay. This is G0. But the original system, I mean the practical system, G delta, was not only this much. It has a few extra modes. How? Nidisha, और कुछ mode बताओ तो?
1 by s square plus s plus 5 or 5 by s square plus s plus 2.
तो दिन ऊपर 1 कैसे सेम रहेगा? वो तो चेंज भी हो सकता है ना?
5 by s square plus twice s plus 1 like that.
So if I wish to take numerical examples, it can be, suppose after 1. Although I changed only the omega n, but zeta can also change. So what happens, you see, this is the nominal. This is the actual G delta. So G delta that I am representing by G0 of S plus delta of S. Okay, so this part, that this mode plus this mode, that is actually my delta. So this is the nominal plant model. This is G0. And this whole thing is the delta. Now suppose when I did the experiment, suppose I was lazy. That is, then I found only 2 extra modes. Then suppose after you have carried out the experiment, you found 2 more. She carried the experiment, suppose she didn't get any extra modes. She was even lazier than me. Suppose she got only G0. But some of us may be very enthusiastic, he has got 10 extra more. It can happen. Then that is immediately you will ask, that is sir, ये तो पूरा hypothetical हो रहा है. आप सोच के बता रहा है 2 एक्स्ट्रा भी हो सकते हैं, 3 हो सकते हैं, 10 हो सकते हैं. अभी ओरिजिनली वो सिस्टम है कौन, राइट? This is a model of a cantilever beam. I hope all of you know the Howrah Bridge, second Hooghly River Bridge, the cantilever bridge. So any kind of cantilever beam. Cantilever means, suppose like from the basement. Here I don't have a long stick. If it is had.
One example is this one. This new river bridge is.
Right. Cantilever simply means, suppose you have a like very aluminium like strip, and that is only in one side that is attached to a basement, and then it is whose length is quite far or quite like this length to weight ratio is very high. Are you getting? If you have a structure whose length to weight ratio is very high, then what will happen? It will be susceptible to vibration. And then that is an easy model, which is called linear truncated model, is that you go for a frequency domain analysis, because originally it is a distributed parameter system. Now for any distributed parameter system, we generally go by the PDE model, partial differential equation model. But working with a PDE model is not at all easy, especially if you have to design a controller based on a PDE model. That will be a nightmare. So often we try to get a linear differential equation model. Then what happens, that is from the frequency response analysis, we try to find out the modes. Modes means where it has those omega n1, omega n2 up to omega n. That is, as long as you have a magnitude of sufficient strength. Okay, so then suppose here this is a cantilever beam. That is, it has in one point it has a sensor, in another point it has an actuator. There you are applying a force, there you are measuring the displacement, and then this transfer function is actually with respect to that displacement. Suppose if this is d1, then capital D1 of S by f of s. That is actually my g delta of s. Now, why unstructured? Because it depends upon the experimental procedure which you carry out. Whether you will be getting 5 extra modes, 10 extra modes, or 50 extra modes, that completely depends upon, that is how perfection the person is taking. So if you add 2 extra modes, then what will be the order of the system? 6th order, that is 2, 2, 2. Now if I add 4 extra modes, what will be the order? 10. If you add 50 extra modes, what will be the order? 52. So there is no fixed structure. This is an example of an unstructured answer. अच्छा लगा? So this matter is about the vibration control. If you see some of my papers, like specifically I work on negative imaginary system theory, that is one of the vibration control techniques. So there, that is mostly negative imaginary that theory started specifically with vibration control. And what is the very peculiar kind of thing, that is, it works with positive feedback. Those who are there in the last semester, you already saw that is this NI theory works with positive feedback. So usually if you see some of the old papers, the area is really very interesting. You will find that he was positive position feedback control. In short, we always use the acronym PPF. PPF, positive position feedback. So anyway, that is an extra information, but this, I didn't want to give that example here, but like that is the, I think, a very good example to understand this term unstructured. That is why this is called unstructured. Now you have understood. That is, it depends upon, that is, how many modes that you are identifying from the experiment. That too depends upon where you are placing the sensors. You see, that is when this, suppose it is a very long cantilever beam, and then this kind of like sensors and actuators, they are either, you might have heard about the PZT or MFC, piezoelectric transducer sensor, or the microfiber composite MFC. Those kind of sensor and actuator we apply, and then from one side you will be applying force, and the other side you will measure the vibration, okay, amplitude of the vibration. Then you have to see, that is, how many modes. How many modes means in the frequency response there will be all peak, right? Now that is like peak of sufficient strength we will be considering, because if the strength or if the magnitude is really very less, you can like eliminate those modes, or simply you can ignore. Ideally, that is G0 plus infinite combination of modes. But when we work with a model, we cannot consider infinite modes, right? Always you have to truncate. Then how many modes will be of our interest? That really matters. So how many modes you will be considering? Whose strength, that is magnitude, can cause some trouble in our controller design. That many modes you will have to consider. Okay, it can be 15 modes, 20 modes, 25 modes, something like that. But ultimately you see, never this model become equals to the original system. Like that is one of the reason why it called unstructured. Secondly, ये delta फोर्थ ऑर्डर भी हो सकता है, 2 मोड्स है, सिक्स्थ ऑर्डर हो सकता है, 3 मोड्स है, देन वो अगर 30 मोड्स होगा उसका ऑर्डर हो जाएगा 60. दैट इज द रीजन व्हाई इट इज कॉल्ड अनस्ट्रक्चर्ड.
But not
Exactly. It can be that is as many modes as you consider, your modeling become that is more perfect, but at the same time you have to then take the headache of considering during the controller design you will have to then work with the 60th order delta. Those are some of the challenges, but anyway here I hope you have understood why it is called unstructured. सिमिलरली कोई अगर तुमको पूछेगा कि तुम्हारे पास ये जो डिले सिस्टम है e⁻⁻st, दैट मींस e सीरीज का एक्सपेंशन क्या होगा 1 प्लस देन st then 1 by factorial to a square t square then 1 by factorial t s cube t cube. वो जो e⁻ जो सीरीज है वो इनफाइनाइट पावर सीरीज है ना. So you might have heard about the pad approximation. Suppose वो e⁻st को किसी ने फर्स्ट ऑर्डर pad approximate कर दिया, किसी ने सेकेंड ऑर्डर लिया, थर्ड ऑर्डर लिया. As you keep on just going for the higher order approximation, the more accurate model you will be getting, but never it becomes equal to the original system. And also depending upon your wish, it depends that is what will be the delta. So again, there is no specific structure, because if you wish to take second order pad approximation, then or third order, fourth order, fifth order, continuously the order increases, right? There is no fixed order. That is another example of unstructured uncertainty. So we'll have to, after onwards, we have to learn how we can model those uncertainties from the real data. Here I am assuming that as if those things are given, but as I said last day, that is we'll have to find this information from real hardware experiments. Okay, so I hope now you have got good ideas or the between what is the main difference between structured or unstructured. Okay, good. We will meet next Friday, but in between there is all of you decide and give me 1 or 2 classes, because since in robust we have missed first few classes, right? All these are mostly I'm trying to build a good initial knowledge.